Hi, in this tutorial we are going to solve a question related to formal charge. The question asks us, give the formal charge if one exists on each atom of the following. Let's start from the first one. In the first option, A, we have a variety of atoms on this molecule. I'm going to specifically select one atom that has a formal charge, this oxygen atom. How can we calculate formal charge? There are two ways. The first one is using a formula, and I will write a formula here. Formal charge Fc equals to number of valence electrons for an atom in the neutral state minus number of bonding electrons divided by 2 minus number of lone pair electrons. If we apply this formula for this oxygen, let's write it here. Number of valence electrons in the neutral state for oxygen is 6 because oxygen is in 6A group of periodic table and it has 6 valence electrons minus number of bonding electrons. Let's look at this oxygen has here one single bond, and in one single bond we have 2 electrons, and we have to divide this one with 2 minus, it says, number of lone pair electrons. When we look at oxygen, we have 2, 4, 6. We have 3 pairs of lone pair electrons and we have 6 lone pair electrons. If we do the math here, we have 6 minus 1 electron minus 6 electrons, and it's going to be minus 1 electrons, meaning that we have a formal charge minus formal charge for this oxygen. That's the first way. The second way, I'm going to write again the oxygen here so that we can deduce another way to calculate formal charge. Okay, so first of all, we have 6 valence electrons for a neutral oxygen atom. In the neutral state, oxygen has 6 valence electrons. And I'm going to check in this specific case how many electrons actually oxygen owns. And we have 2, 4, 6 valence electrons, 6 lone pair electrons, plus we have a single bond here. In this single bond, we have 2 electrons. One electron is contributed by oxygen and the other electron is contributed by sulfur, meaning that in this single bond, one electron belongs to sulfur and one electron belongs to oxygen. So basically, these 2 electrons are shared equally. It means that we have 1 extra electrons in addition to these 3 lone pair electrons. In total, we have 7 electrons around oxygen, meaning that I have 1 extra electron than the neutral oxygen, meaning that we should have a negative charge. So that's the reason. Let's apply the same principle for the option B. Again, here we have a negative charge or a formal charge, let's say -1 formal charge for this oxygen. Why? If we apply the formula, we will end up with -1. But again, let's follow the second way. We have 2, 4, 6, and also from this single bond, I have 1 extra electron. So this oxygen is surrounded by 7 electrons, meaning that it has one extra electron than the neutral oxygen. Let's check this sulfur here. Sulfur, we know, also 6 electrons because it's from 6A group. In its valence shell, it has 6 electrons in the neutral state. But let's look at here. This sulfur, I'm going to write it here. Sulfur it has a lone pair, and it is surrounded by 3 single bonds, meaning that sulfur owns exactly 2 electrons of this lone pair, and from this single bond it owns 1 electron, and from the other single bond it has this 1 electron, and from this single bond it has 1 electron. So meaning that it has 2 plus 3, 5 valence, 5 electrons in this state. But we know that in the neutral state sulfur has 6 valence electrons, so this one has 1 missing electron, meaning that it should have a positive formal charge. So this one has a positive formal charge, this oxygen has a negative formal charge. Again, in option C, this oxygen has a negative 1 formal charge, and in the other option, this oxygen has a negative formal charge. You may ask, like, this sulfur, what is the formal charge of this sulfur? Again, like, it doesn't have any valence, any lone pair electrons, but it's surrounded by how many electrons in the bonds? So 1 electron from here, 1, 2 electron. In the double bond, actually we have 4 electrons, but 2 is contributed from sulfur and 2 is contributed from the sulfur. So we have 2, 2, 1, 1. In total, for this sulfur is surrounded by 6 electrons, and sulfur has 6 valence electrons in the neutral state. That's the reason why we have 0 formal charge. But this oxygen has a negative 1 formal charge. If you follow either way, you will end up with the same result. Thank you so much for watching this video.